The idea of a confidence interval for one population mean. A confidence interval for one population mean is used when you have one population, the characteristic you are interested in is quantitative, and you want to estimate mu, the unknown mean of the population. Here's the general idea. Our first step in estimating the population mean is to take a sample from the population and compute the sample mean. Due to sampling error, though, we are almost certain that this sample mean is not equal to the population mean. So we want to go a little bit above and a little bit below this value to get a range that we are pretty sure contains the population mean we're looking for. How sure we want to be is referred to as the level of confidence. So our second step in the process is to select this level of confidence. Values are commonly selected as 95%, 90%, or 99%, but any large percentage is possible. Now we need some background information before continuing. Recall that on a standard normal distribution, 95% of the probability is between minus 1.96 and positive 1.96, and that these probabilities generalize to any normal distribution. That is, there is a 95% probability that any normal is between minus 1.96 and 1.96 standard deviations of its mean. From the study of sampling distributions, we know that x bar will, under certain conditions, have a normal or approximate normal distribution, with mean mu and standard error, that is, standard deviation, sigma over the square root of n. If x bar is normal, then there is a 95% probability that x bar is within 1.96 standard deviations, that is, standard errors, of its mean mu. Therefore, if we add and subtract from the sample mean the quantity 1.96 times the standard error of x bar, we will be 95% confident that we have captured the actual population mean mu. Assuming the population standard deviation is known, this concept generalizes to any confidence level by simply changing the z-score based on the desired probability. Thus, step 4 in the process is to find the z-score so that the desired level of confidence is the probability that a standard normal is between that z-score and its negative. And then step 5 is to add and subtract the z-score times the standard error to the sample mean x bar. In other words, the values in a confidence interval are a given number of standard errors above and below the sample mean, where the number of standard errors depends on how confident you want to be. Note that the concept is similar but slightly different if sigma is not known. The sample standard deviation s is not exactly equal to the population standard deviation sigma. So adding a z-score, for example 1.96, times s over the square root of n is not the same as adding the z-score times sigma over the square root of n. That is, using the z-score will not give you the correct probability, for example 95%. So instead of z-scores, we use t-scores on a t-distribution, which is similar in shape to a normal, and thus in this case we are adding and subtracting a given number of estimated standard errors to x bar.
Created using Powtoon.